Now this video is going to look at principal component analysis with actual data and a more complicated data set, and we're going to revisit our friend the iris data. So you'll notice the code that I have here is got a lot of stuff in here. We're not going to use all of it right now. We're going to revisit this code shortly, but we first want to just look at only principal component analysis. So over here, we're going to copy iris into a data frame. And again, you don't have to do that, but I believe it to be a best practice to always copy your data into a temporary variable that you can mess around with, and you don't mess up your original data set. So I'm going to copy that guy over. And if I type in df, you can see I've got 150 of our irises. We've got our setosas, versicolors, and virginica irises. And then we are going to, and if you see, we have, this is column 1, column 2, column 3, column 4, and this is the species. So we are going to do our principal component analysis on these 4 columns here. So the command is principal component, our data, df, and we're going to use, you see like nothing and then there's a comma. That means use all of the rows. So we're going to use all of the rows, and we're going to use columns 1, 2, 3, and 4. We are going to center this and scale it. That's basically, we're going to standardize the data. We are going to subtract out the mean and divide by the standard deviation. So that's, you should always center it and always scale it. So let's do that. And we put our answer into PCA right there. And if we look at that, if I just type in PCA, you can see that we have 4 variables: sepal length, sepal width, petal length, and petal width. And we have 4 principal components. Why? We had 4 variables. We're going to have 4 principal components. Principal component 1 is made up of this mathematical formula: 0.52 of sepal length minus 0.26 of sepal width, 0.58 of that, 0.56. Now, in a previous lecture, I said you can tell a story or explain a principal component, and you can do that by looking at the coefficients. So the largest magnitude variables here are this guy, this guy, and this guy. They're all positive, and they all are, it doesn't have to be positive. This guy, the largest one, is negative, so that we just care about magnitude. But you can see here that this, and this all have 0.58 and 0.52. So I would say that if I were to describe this, as I would say these are going to be principal component 1 describes flowers that have large sepal length, large petal length, and large petal width. Principal component 2 is made up primarily of sepal width. So these are the first 2. So this is what these are. We're going to use these principal components, and we're going to see what we get. So let's go back here. And now, how many of these principal components do we need? We got 4 of them, and we can use as many as we want. So how many are we going to use? Well, let's do a scree plot. And there's our scree plot. And you can see that our first principal component number 1, has as much information as 3 variables. Principal component number 2 has as much information as about 1 variable. Principal component 3 has as much information as maybe half a variable, and principal component 4 has a little bit more than 0. So I would say that I would probably just use 2 principal components, principal component 1 and 2. And I bet we can get a lot of information for just using 2 variables instead of 4. So let us predict using principal component analysis, this guy right here, here's our model, and we're going to use the data frame. So we're going to run that command. And if I type in and we're putting the answer into df new. See, there it is. We've got principal component 1, 2, and 3. And if I just do the whole thing, df new, you can see I've got 150 rows and I've got all 4 principal components here. We don't need all 4, we're only using 1 and 2. So what we're going to do is copy 1 and we're going to copy principal component 2 and we're going to put them into our friend df and we're going to name it PC1 and PC2. We could name it anything we want, but I like to keep it PC1 and PC2. And there we go. So if I say df, whoops, let's make it the whole thing. You can see now we have data frame. We've got all of our original data. We've got our species. And now we've got principal component 1 and principal component 2. Now let's graph this guy. We're going to plot principal component 1 and principal component 2. And we're going to color it by the species. And let's see what we get. I'm going to make this larger to really. So let's plot that and see what we get. Voila. And you can see right here, we've got a big clump of, I think this could be setosis for all I know. I don't know which one these are. But you can see we've got one group of irises here. We got another group right over here, and we got the third group over here. Now this isn't perfect, of course, but you can see that with 2 variables, we can do a really nice job of separating these iris species. So that's what we have done. We've used 2 variables instead of 4. So let's stop here, and we're going to now discuss a different type of variable reduction techniques.